All right, let's go through some examples of our graphs now for y equals sine and cosine. Starting with y equals 3 times the sine of x. All right, so let's think first of all the transformations that are involved here. All right, well, we only have one number involved, and that is our a value from the transformation format, which is a vertical stretch by a factor of 3. All right, so since it is a vertical stretch, none of our horizontal values are going to be changing. So the horizontal values on our axis are going to be the exact same ones that we have used before, which were 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are always going to be the values that we will use on the x-axis unless a horizontal change has taken place, meaning a horizontal shift or a horizontal stretch or compression. Now, remember that our original graph, y equals sine of x, went between -1 and +1. Well, this is a vertical stretch, which means instead of going between -1 and +1, we're going to be multiplying those values by 3. So our graph is actually going to go between 3 and -3. And so that's what our graph will fall between. Now the shape of the graph is still the same, which means if you think about the sine of 0, the sine of 0 is 0, and then that leaves you with 3 times 0, which is 0. So 0, 0 is still going to be the starting point for our graph. Now, when I say starting point, it's not really the starting point because our graph does go to the left and to the right forever, but it's going to be the starting point for this one cycle that we are going to be graphing. All right, so then the next x value is where your maximum will occur. And so at pi over 2, you'll have a maximum at 3. At the next x value, that's where you will cross the x-axis. At the next x value, you will have a minimum. And then the next x value is going to be on your x-axis. And then we just sketch the curve going through those 5 points. Now, if you'll remember, the imaginary axis that goes right through the middle of this graph is called your central axis. That's going to be real important a little bit later on. And so now let's think about your domain. Your domain goes from -infinity to infinity. Range here falls between -3 and +3, and those are on the graph. The amplitude will be your distance from the central axis to your maximum, which is an amplitude of 3. And then the period is your length of one cycle. This is the graph of one cycle. And the length of this is 2 pi. All right, next example. Transformations that we're looking at here. We have a 2, which is going to be a vertical stretch by a factor of 2. And then we have the 1, which is a shift up 1. Now what we want to do with this is we want to always get used to starting with where your central axis is located. All right, so let's graph where the central axis is, which is going to be at 1. So at 1, we're going to put a dotted line right here. So we want to sketch where the central axis is. The only thing that's going to affect your central axis is a shift up or down. That tells you this number, whatever you're adding or subtracting on the end of your function, that will tell you where that central axis is located, whether it's shifted up 1 or down 5 or wherever. That will tell you where the central axis is. So you draw a horizontal line. All right, so now when x is 0, let's think about the graph of this. Well, the sine of 0 is 0. Times 2 is still 0. And all you're left with is 1. All right, so that means when x is 0, you're going to be at 1. Now, we do have a vertical stretch by a factor of 2. And if you'll recall from the other notes, the vertical stretch, what it tells you is what your amplitude is going to be. And the amplitude is the distance from your central axis to the highest point on your sine graph. So that distance here is going to be 2. Well, that also tells us that our graph is going to go up to positive 3. And if you go down 2, that's going to put you at negative 1. So the distance here is 2, and the distance this way is 2. Now the x-axis values are still going to be the same because there's no horizontal change on this graph. So we're going to have x-axis values here of pi over 2, pi, 3 pi over 2, and 2 pi. Now, the sine graph is always going to start at your central axis when x is 0. So you're going to set, well, as long as it depends on the transformations, but you're always going to start on the central axis. And then you're going to go up to the highest point, back down to the central axis for the next x value, and then to your minimum for the next x value, and then back to the central axis for the last value. So what we're going to do is we're just going to plot the points. So at the next x value, you've got a high point, central axis, low point, central axis. And that will be your sketch for your graph here. All right, so the domain of this, remember that we are only sketching one cycle. The domain is not 0 to 2 pi. The domain is negative infinity to positive infinity. It does go to the left forever and to the right forever. Your range, this does have a minimum and it does have a maximum. So your range goes from negative 1 to 3. And your amplitude is the distance from the central axis to the highest point, and that distance is 2, which also is the same as your a value. That will always be the case. And the period goes between 0 and 2 pi, so the period has a length of 2 pi. All right, the next graph here. Think about our transformations. All right, so we got a 4, which is your vertical stretch by a factor of 4. And then we have this, which is down 2. Now, the minus 2 also tells us where that central axis is. So that's what we want to sketch first. Let's sketch where that central axis is. All right, so at negative 2, we draw the horizontal line here. We are going to be using the same x values as we did before, which were pi over 2, pi, 3 pi over 2, and 2 pi. our graph will start on the central axis, and then it's going to go to the highest point. Well, 4 is your vertical stretch. That is also your amplitude. So if you go up 4, that is where the highest point is going to be. The next x value will put you back on the central axis, and then you'll go to the lowest point, and then back to the central axis once again. So when you sketch the curve, that's what your graph will look like. So your domain here, as before, is still going to be negative infinity to infinity, with the range between negative 6 and positive 2, with an amplitude of 4, and the period is still going to be 2 pi. All right. The next graph we have, we're going to start out with our transformations. We have this value, which is a vertical compression by a factor of 1/2, which also will be the amplitude. And then we have this, which is a shift to the right pi over 2. Now, on the other ones, what we did is we started out by graphing the central axis. Notice there is no shift up or down on this, which means our central axis is the x-axis. So we don't need to redraw that right here. Now, what we do want to start out with are figuring out what the values on the x-axis are that we're going to be using. Now, normally we would have used pi over 2, pi, 3 pi over 2, and 2 pi, and we would stop right there. Now, if you think about this shift right here, this is to the right pi over 2, which means we would be taking this whole graph right here and shifting it to the right pi over 2. Shifting to the right means that we are adding pi over 2 to each of those x values. So the 0 point that we usually started with is now going to be right here. So if you think 0 plus pi over 2, that's going to give you pi over 2. The pi over 2 point is now going to add pi over 2 to that, which is pi. And then pi plus pi over 2, that's 1.5 pi, or in other words, 3 pi over 2 is how you want to write it. 3 pi over 2 plus pi over 2 is 4 pi over 2, which is 2 pi. And then adding these together, you get 5 pi over 2. So we're going to have pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. Now remember that on this graph and all the other ones up to this point, our last point was located at 2 pi. That's not going to be the case this time. The last point is going to be located at 5 pi over 2. Now, we did say that we have a vertical compression of 1/2, which means the y-axis values are going to be positive 1/2 and negative 1/2. Now, normally our graph started right here, but because we are shifting to the right pi over 2, this point on the central axis is now going to start right here. So we go from here to the high point, back to the central axis, to the low point, back to the central axis again. So we always go up, and following the curve right here. Now, the things that we haven't approached yet is normally our graph goes up like that. What would change that would be a reflection over the x-axis. If we have a transformation that is a reflection over the x-axis, our graph would start out by going down first, and then like this. Okay? All right, I'm going to stop this video right here and allow you to catch up with your notes, and then I'll put out a third video with the remaining examples that you can look at.